Well, welcome everyone. Thank you for joining us this afternoon. This is officially the kickoff for the second series of the GTM Talks, which is a webinar series that highlights some of the exciting research, monitoring, and stewardship efforts here at the GTM Research Reserve. Just a reminder that today's webinar is being recorded and will be available on our YouTube page as soon as we get it edited and all fixed up. This webinar today is called Sea Level Rise and the Coastal Wetlands in the GTM Research Reserve. It is the first webinar of the second round of offerings here, and we'll focus on the GTM Research Reserve's management plan goal of enhancing our understanding of impacts from sea level rise and climate change on our estuarine systems using science-based information. My name is Abby Kuhn, and I'm with our coastal training program at the GTM Research Reserve. Before we get started, I do have a few virtual housekeeping reminders. Let's see here. Just a reminder that you should have entered the meeting today on mute. So we will ask you to please keep yourself muted while the presenters are presenting to help prevent any background noises. You are more than welcome to share your video if you would like. We'd like to see all of your familiar faces. And then also along the bottom of your screen there should be a participants tab. And this will allow you to give nonverbal feedback and also give you the ability to raise your hand to ask questions, which will be at the end of the presentations today. And then also you'll see an option for the chat box, and we'll have you all introduce yourselves in the chat box here in just a second. And it will allow you to introduce yourself and also ask any questions that you may have throughout the presentations. So while we get Dr. Shirley's presentation pulled up here, we'll go ahead and ask you to introduce yourselves in the chat box, and I will give you the prompt here in just a second. All right, can everyone see Dr. Shirley's presentation pulled up? Awesome. Well, I'll also introduce Dr. Mike Shirley. So Dr. Mike Shirley has held the position of director at the GTM Research Reserve since 2007. He also serves as the regional program administrator for the Florida Department of Environmental Protection's East Coast Aquatic Preserve Program. Mike has a PhD in marine science with a minor in environmental toxicology from North Carolina State University, a Master of Science in Biology from the University of West Florida, and a Bachelor of Science in Zoology from the University of Rhode Island. Dr. Nikki Dix will be speaking after Dr. Shirley. She has been the research coordinator at the Reserve since 2013. She has a PhD from the University of Florida. And as the research coordinator, Nikki establishes research priorities and oversees long-term monitoring in the context of regional, state, and national objectives. And last, but certainly not least, Pam Markham has been the lead biologist with the Reserve since 2014. She earned a Bachelor of Science in Biology from Arizona State University, a Master of Science in Coastal Zone Management and Marine Biology from Nova Southeastern University, and is pursuing a post-baccalaureate in statistics from the University of North Florida. and she leads our vegetation monitoring and has led the charge of our Sentinel Site application modules in Pellicer Creek, which you will hear more about today. So Dr. Shirley, take it away.
Okay, thank you, Abby. Thanks to everybody coming into this Zoom meeting. Wish we were all together in the auditorium. I know that's a lot more interactive, and I certainly enjoy being able to tell folks about what the Reserve's been up to and tell you about important challenges that we all face in our community and trying to keep this reserve, its biodiversity conserved. And so my talk today is going to be an overlevel, kind of an overview of the story of sea level rise in our area. As you think about sea level rise and at a reserve, we do a lot of what's called adaptive management, where we try to figure out, what's the best way to manage the site, but it's not a static thing. We dynamically change our priorities based on what our science tells us. And over the last few years, our science has been telling us that sea level rise and climate change has become very important in order to protect not only our coastal communities, but our habitats and natural infrastructure. We really need to be focusing a lot more on sea level rise. It will impact not only habitats, but places we live and water quality in a way that is unprecedented. So having said that, another cool change that happened this last couple of years is the reserve system is now not only within DEP as we always were, but we're also in this new Office of Resilience and Coastal Protection. And that's a good place for us to be, because that's the office that the state is relying on to really help out with a lot of their resilience initiatives. So the science at the reserves is directly making a difference statewide. So the topic of my talk today is how do we enhance natural systems to adapt to responses in sea level rise? And it used to be in our world of restoration, we would simply look at a historic map and say, hey, that marsh used to be there and now it's filled in or damaged, let's restore it back to where it was. Well, now we have to kind of think in terms of sea level rise and how that changes what the future will be. So restoration is become a lot more complex, and the concept of enhancing natural system, I think, is becoming a more important topic. Now, one of the key things of understanding sea level rise and how you manage for it is to recognize right from the start that you're really managing for change. Sea level rise rates are not static, they're dynamic. Unfortunately, they've been increasing. And our ability to adapt these systems and to basically affect the way we live on the coast will really be important for us to keep track of what's happening with sea level rise and respond adequately. One of the things the reserve does very well is we set up a series of canaries in a coal mine, I guess we could call them, of sentinel sites, looking for habitats and species that are particularly sensitive to a stressor that we're concerned of, in this case, sea level rise, and start monitoring these long term so that we have a way of detecting change early on so that we can be proactive and hopefully be able to protect these habitats that are not only important for the species around us, but for fisheries. Marshes, for instance, which is one of our sentinel sites, is very important for protecting our homes and places where we work from the surge of storms, and they help as buffers and water quality protectors. So very important in all of what we do at the reserve is not only to look at the habitats that we protect and conserve, but how these habitats serve our local community, and looking for ways that we can both protect these habitats that safeguard the places we live. Now, the Research Reserve boundary, as many of you know, I must say, a two-component reserve this past year. We actually have managed to fill in the gap between the southern northern component, and the city of St. Augustine stepped up and asked us to to include the waters that are outside the city of St. Augustine as part of the reserve. So these maps I show here are going to be updated, although it won't fit on one page. But the reserve is now a one-component reserve connected with the city of St. Augustine, and we're very excited about that. And it's a nice change. It's something that happened over the last few months. The federal NOAA, our federal partner, approved this, and kind of went on behind the scenes. But the neat thing about this is now the waterways, which really don't see a boundary, have no boundary. And working with the city of St. Augustine, we've already got a great plans of working with them and things happening you'll hear about someday in the future. One of the things that we did early on when we were concerned about sea level rise is we partnered with the University of Florida, and through a grant from the Research Reserve Science Collaborative, we did a project called Planning for Matanzas. Many of you are probably familiar with that project. It ended in 2015, which seems like a long time ago, but it wasn't really that long ago. The main thing this project did for us was help us understand how sea level rise was going to affect our habitats along the coast, particularly helping us understand which habitats were most sensitive, with marshes really coming to the top as the most sensitive habitat to sea level rise. Also looking for ways that these habitats could migrate inland to see, okay, sea level rise happens, will habitats simply migrate towards the inland areas. Unfortunately for salt marshes, our Northeast Florida topography has quite a bit of a jump up between even areas that aren't developed, between the natural lands that are the forests and the marshes. So it's going to take some help. The marshes are going to need our help, I think, to move inland. And that's not part of this talk, but I think as we talk about long-term resilience and planning for the future, trying to identify those places where marshes can move in and still provide those services that they do to our community is going to be important. The other thing that this project did is it modeled future development. There's been a lot of modeling of future development, but this one did it in the reflecting on sea level rise. So not only folks moving from South Florida to North Florida, but folks moving from the coast inland, and it have a pretty dramatic effect. I'm going to summarize it in one of these next slides. But I think most important, this started the dialogue of sea level rise and things we could do and planning that would be needed. And planning takes a long time. So 2015 was a good time to start thinking about and starting to put the pieces in place. And there has been a lot done since 2015. And I think credit some of the folks that were involved in these first meetings. And one of the most important part of this project was to get the folks in the room and starting having frank discussions about sea level rise. Now, one of the things that happens with sea level rise, as I mentioned, our marshes are very sensitive. Well, if we get a sea level rise increase of 2.5 meters, which is out there probably in the 200 to 300 year range, we'll lose 95% of our marshes. They just will be flooded. Marshes cannot tolerate being underwater through the tidal cycle. And so that got us thinking, well, if we're going to lose this much marshes, where are they going to go? Unfortunately, as I mentioned, there's not a lot of places for them to migrate to. Either the landscape has been hardened so they can't migrate, or those areas where they can migrate to need further protections to be able to allow the marshes to migrate. The other thing was looking at population increases. We have folks moving to St. Johns County, as we all can see from living here, quite rapidly, and it gave us an estimate of what we expect by 2060, increase of 179%. And in addition, when we get a 1 meter increase of sea level rise, which is a reality in less than 100 years, we'll see folks moving from the coast inland, and all that puts additional pressure on our watersheds. And so as we start thinking about planning for water resources and marshes and other habitats, we need to be thinking in terms of planning side by side the future in terms of the development of the watersheds, as well as where do we set aside places for important habitats and water resources. Now, one of the things we've done at the reserve, and we started this a number of years ago, and both Pam and Nikki are going to give you a lot more details on this, so I'll go through just very quickly the general piece of this, is we understand that marshes are really dependent on a balance between balancing sea level rise with accumulating sediments. And they accumulate sediments by actually trapping sediments because their structure is out in the estuary. They can trap sediments, but they also break down, and the plant material itself becomes the peat within the marshes. And so those two things start to help the marshes take care of itself as the water increases, the levels increase. Now, in the long term, this has been something that's managed to keep the marshes in place, and in some cases even expanding when sea level rise rates were less. But as sea level rise rates increase, we're starting to become concerned, and we'll show you some data later on these talks, that the marshes no longer accumulate enough sediment or make enough sediment to be able to keep up with sea level rise. And so we're at a very important tipping point. So these Sentinel sites, as we call them, are throughout the reserve. Again, Nikki and Pam will give you more details, but essentially they're in different types of marshes, because different types of marshes are going to respond differently to being able to accumulate sediment and to sea level rise. They also, some of these now are actually becoming sites where we're seeing mangroves coming in, which has a whole different impact on our marshes and its ability to accumulate sediments. So I think all these variables, one, it's cool to see these projects all in different marshes, but also makes us scramble because we have a lot of different variability within these marshes, as you'll see in some of the summary slides. So as we look at our research that we've done in the marshes, we basically are most interested in the slopes. If you look at the trend lines here for each of our marshes, and this is work going from spring of 2018 to fall, or 2013, sorry, to fall of 2018. And there's even more data now that Pam and Nikki will report on. But the slopes tell us how fast the surface elevation of these marshes are increasing. In some cases, they're not changing at all or very little. In other cases, they seem to be putting on a pretty good increase in surface elevation with time. Most of them look like they're flat lines, which means, you know, they're basically just keeping at the same elevation. And so this gives us a very precise way of monitoring the surface elevation in the marshes. So the next story we have to put on top of this is what's happening with sea level rise. You know, what kind of changes are we seeing in sea level rise? And many of you are very familiar with this graph. This is the 80-year graph of sea level rise rates. And it comes out of various offices. Primarily, it's coming out of NOAA from the data coming out of the National Water Level Observing Network stations. We have one, our nearest one is in Mayport. And it tells us that sea level rise is at 2.62 millimeters per year. And if, just let me back here. If we look at these slopes, our fastest marshes in terms of accumulating substrate is at 4.4. So these are going to do just fine at that kind of a rate. The others are just either barely keeping at that rate or they're much less than that rate. So this 2.62 gives us a little bit of concern, but what's more concerning is if you look at the last 20 years of sea level rise for our region, again, this is the Mayport station, it's accelerating. And this is not, you know, this is not new news. Pretty much if you look at any information on sea level rise, it's pretty clear that over the last 20 years, we've seen accelerated sea level rise rates, and we're likely to see them accelerating some more. Again, sea level rise is not a static, the rates are not static, they're dynamic. And at this point in time, all the science that we've been reading and learning about tell us that sea level rise rates are likely to increase with time. They are just going to, because of changes in the Earth's climate, melting land-based ice, and changes in the way the circulation happens in the oceans. When we look at Mayport, we get a slope a change of sea level of about 6.12, which is higher than any of the marsh's abilities to be able to accumulate sediments. However, when I looked at this graph and first plotted it out, I noticed there were some outliers in here, some outlier points from when we have hurricanes. So to be conservative with our estimate, I removed those outlier hurricanes, so those extreme water level events wouldn't be in there. I still get a fairly high slope of sea level rise of 5.2, which is still more sea level is increasing than our sediments or surface elevation in the marshes are able to keep up with it. So again, a reminder, this is what our marshes are doing, 4.4 millimeters a year, down to almost no increases in surface elevation. Now, on the bright side, and where the reserve is really focused on, is looking for solutions. We have different ways that we can help the marshes. One is a technique called living shorelines, and the reserve, along with a lot of its partners and universities, particularly University of West Florida, have been looking at different ways of protecting the shorelines and augmenting their ability to the marsh's abilities to not only stay in place, but also trap sediments. And so living shorelines are essentially, they're not a new term anymore. It's pretty much something that's allowing, that allows the marshes to survive. It's a less hardened structure than, say, a seawall. And these allow the marshes to have a lot of its natural functions, like pollution abatement and protecting the coastal areas, the homes and buildings from storm surges. Also, they help accumulate sediments behind the living shorelines. Another technique, and this is it's not new for the United States, but new for our region, is actually taking some of the dredged materials that come out of the intercoastal waterway that would typically not be beach quality and would have to be trucked inland, and look for ways that these sediments could be put on the marshes. Now, the real challenge here is doing it in such a way that you don't bury the marshes, because too much sediments is not good for the marsh. And you have to make sure that the sediment type and quality is compatible to the critters and the marsh plants, or you'll end up with pretty much a mud flat. And so there is work being done by the Army Corps of Engineers. They do a lot of work in the Louisiana area and areas where marshes are disappearing much faster than here. There's a new project up near Jekyll Island in Georgia that they're monitoring very closely. So someday in the not too distant future, we'll be piloting projects to test out this technique and help to augment the marshes. So in summary, basically, it's time now to start planning for marshes to migrate and to figure out ways that we can help marshes continue to provide those services they do for us for water quality protection and helping protect us from storms. I think it's important to realize that our main port station is close, but it's not close enough for areas like St. Augustine and Flagler County and St. Johns County, that it'd be, there's a gap in the National Water Level Observing Network. And so we've been working with our partners and our state agencies to see if we can figure out ways to get those Enlon stations filled in the gaps. There's one here in Northeast Florida, gap, and there's one down in Naples in Southwest Florida that could use an Enlon station. And also the beginning of studies and stakeholder meetings, which we actually have a grant this year now to be able to move on this, to look at thin layer placement of those dredged materials into the marshes. And last but not least, I think we need to get a handle on the best ways to do living shorelines. We're still learning. Initially, we were doing things with shells and plastic bags, and we found that plastic was a real mess. And now we're starting to move away from that and discouraging that and looking for other types of living shorelines, all compatible with the wave energy these marshes receive. So that was a high-level summary of where we're going. Nikki and Pam have much more details on these projects that are happening within the reserve. My phone number there is my office number, but if Abby could share my email in the chat, so if folks want to email me, you're more likely to catch me right now because we're still under the telework situation. and I'd be glad to answer any questions you may have, and also email me if you need any follow-up information. Thank you.
Great. Thank you so much, Mike. That was a wonderful overview of sea level rise and what's happening locally, and a good overview of some of our projects that the reserve is working on. So make sure, because we want to get through our other presentations, if you have a question, feel free to type that into the chat box so that way you don't forget it. So that way you can focus on all of the other presentations. And at the end of our presentations, we will have time for a Q&A session, and we'll be able to ask all of our presenters the questions. So our next presenter is Dr. Nikki Dix, who's going to be sharing another overview and a little bit more with data as well of some of the long-term monitoring within the coastal wetlands that the reserve is working on.
All right, thank you. And thanks, Mike, for setting this up very well. So before I get started with my slides, I just want to acknowledge Pam and Shannon and Silas, who are the ones that are out there in the marshes doing most of the hard work and managing the data and all of the detail that goes into that. So thank you to them. All right, so in terms of what we do to monitor wetlands in the reserve, I kind of lumped it into three main objectives that you see here. The first one is just general, looking at how the estuary changes over time and what is the general condition of our marshes. The second one is looking at the effects of warming and the effects of shifts in foundational vegetation. And what I mean by that is what Mike was alluding to with the mangroves moving in and replacing our marshes. And the third one is looking at the effects of sea level rise on our marshes. So I'll go through what we do in those three categories. So the first one is conditions over time. And Mike showed this map. We've been monitoring these 6 sites since 2012. The 6 sites were chosen randomly, and they represent, as Mike said, different types of marshes. So we get a good sample throughout the estuary and can make some, conclusions on the whole reserve with these 6 sites. And you can see in the background of this map, there's a habitat map. So you can see the Spartina Marsh in green, High Marsh, which is mostly made of Batis, which is a succulent, in orange. And then you can see the Juncus, which is the black needle rush, in purple. And then you can see how the mangroves are starting to move in, especially in the southern component in blue. So I should say too that habitat mapping is something that we're getting into in terms of being able to look at change over time. We completed a habitat map last year, and we'll be able to do that again in the future to look at changes in aerial extent of the different types of marshes. What I wanted to talk most about was our protocols and our data that refer to the vegetation monitoring. So those 6 sites that we visit are a combination of 2 different national protocols, and one of them is the Research Reserve System protocol. So that's the one I'm showing here. And the cool thing about this situation is that the data that we produce is standardized with all of the other reserves around the country. And we submit it to a centralized data management office, and everything is available for download by anyone who wants it. And the data is not just the raw data, but it comes with metadata reports describing all of the methods and any of the notes and all of that. So people who want to do kind of a nationwide look at marshes have this huge data set available to them with that everybody has been using standard methods for. And then the other program that we've collaborated with through this is the National Park Service Southeast Coast Monitoring Network. So they have national parks along the Southeast in which they're doing the same protocols we are. So our data can again be compared at this scale. So on the ground, here's kind of what it looks like. This is one of our sites, Moses Creek. And the platforms have actually changed since then. You can't really see them as much anymore. But at each one of our 6 sites, we have 3 sets of platforms like you see here. And each one of the platforms is set up like in this diagram. And there are 5 vegetation plots, those squares with the V. And that's where we look at the percent cover of the different vegetation species. And we also measure canopy height. A couple of the plots, we look at stem densities to get an idea of, you know, the amount of biomass there from the plants. And then very importantly, in the middle of each platform where you see the R, that's where we have a deep, broad surface elevation table, which I'll talk about later. And that's the data that Mike showed, that he was looking at the slopes compared to sea level rise. So there's some challenges with this monitoring that, you know, we don't want to walk in the marshes that we're monitoring long term. So we build platforms over them so that we don't damage them. The platforms are, you know, made of, they used to be all made of wood. Now we're switching to a fiberglass grate material that you see in the green on the right. It's more durable. It also allows the vegetation to grow through it because it lets light down to the bottom. But one of the big challenges is that we set up these platforms at the edges of our tidal creeks, at the edges of the marshes, and they only go 10 meters or about 30 meters into the marsh. So all of the data that we're looking at are basically from the edges of these marshes, and we're not getting a full picture of the whole shore to upland marsh area. And another challenge with that is the fact that these tidal creeks are often eroding. We have a lot of, I think my next slide shows that too. Yeah. So we have a lot of plots right on the edge of the tidal creek that have been eroded away, and we can't sample them anymore. More have been eroded than have been accreted or gained. So over time, we're losing our ability to sample those plots. So, you know, we also have a couple of sites that have shore to upland transects, which are better because you're looking at the entire marsh surface, like I was saying. But those are difficult because you can't, it's not as easy to build huge platforms that you don't have to walk through the marsh to access. And so the ones we have at Moses Creek, we go to about every 3 to 5 years, and we walk in the marsh. And we found that over that amount of time, they seem to be able to heal themselves. The 3 that we had at Pellicer Creek, we had to abandon because we walked through them once and they left a scar that didn't go away. I think it's finally starting to go away. So we decided to not monitor those anymore. And we are putting in new, or we already have put in new transects in Pellicer Creek with platforms. And that's part of our Sentinel Site project that Pam is going to talk more about. So I'm going to go through some of the results that we've seen since 2012. And these are all from these 6 sites from the marsh edge plots. So not the shore to upland transects. This is where we have the most data so far. Okay, so these pie charts are of percent cover. So you're looking at, when the biologists are out there looking at the plots, they have a 1 meter quadrat that they lay down in the marsh, and they estimate, you know, how much of the different vegetation species they're seeing. And so these are averages over time. And the dark blue is unvegetated. So that's just when you look down, you're seeing bare ground. And the reddish orange color Spartina. So you can see that most of our sites are dominated by Spartina alterniflora. And there are some Batis coming in. So if you look at the Hat Island site, and by the way, these are on the screen from north to south. So the Hat Island site is actually interesting because in 2019, we saw some new Batis coming in that we hadn't seen historically. And then in East Creek and Washington Oaks, we're seeing more mangroves this past year than we had in the past. And that's the Avicennia germinans, is the black mangrove. So we are seeing a little bit of change over time, but now I'm going to go through graphs that show you the percent cover of these species over time for each site. And the main take home is that the vegetation cover doesn't seem to have been changing very much over time, at least since 2012. So here's the first one. This is Pine Island, and you're looking at cover of basically bare ground, unvegetated, and Spartina alterniflora. And so you can see what we sample 2 times a year, the fall and the spring, and we have some ups and downs, but it's pretty stable over time. The next one is Hat Island, so just south of where the Guana River meets the Talamato River. And it looks very similar to Pine Island with mostly Spartina. And then you can see in 2019 that little jump in Batis, which is that succulent high marsh species. The East Creek site is south of St. Augustine, west of Moultrie, or east of Moultrie Creek, excuse me. And you can see that's mostly dominated by Spartina as well. And then you can also see the mangrove cover jumping up, especially in 2019. In Moses Creek, very similar to a lot of the other ones, dominated by Spartina and not a whole lot of change over time. And Pellicer Creek's an interesting one. It has probably the most species of any other site, and it's dominated by juncus, the black needle rush. We had an interesting peak in the fall of 2016 after Hurricane Matthew, but after that it went back down and kind of stabilized. And we're getting a little bit more Spartina in the past couple years. And then Washington Oaks is another one of those where we've seen a jump in mangrove cover, especially in 2019. And this one is actually dominated by Batis, that succulent, really green species. So that's an interesting site to watch too. So now I just want to touch on some of the work that we've been doing to look at the effects of warming and this mangrove migration into Spartina. And it's mainly through the work of this National Science Foundation funded project. And it's led by Samantha Chapman at Villanova University. I think I saw her name on here. Yeah, hi Sam. And a lot of other researchers around the country and locally are involved in this. And the project's called Wet Feet, stands for Warming Ecosystem Temperatures in a Florida Ecosystem Experiencing Transition. So this is a great aerial shot of one of the southern site. There's 3 sites in the reserve where they're studying this. And you can see how there's these little warming chambers out there in the marsh. And these are warming the air temperature by about 2 degrees Celsius to simulate climate warming. And so they have plots with warming chambers, plots without warming chambers, plots with just marsh, and plots with mangroves and marsh. And so the whole idea can kind of be summed up by this conceptual diagram on the left. And what they're trying to figure out is, will the mangrove invasion and warming increase the elevation of the marsh or decrease the elevation of the marsh? Because there's a bunch of different processes going on at the same time that may have different effects. So warming and mangrove invasion can increase root growth, and actually when you have more root biomass underground, that increases the elevation of the surface. But warming can also increase decomposition and break down that material. So if you have a quicker rate of decomposition, you might lose elevation in your marsh. And so they're measuring the detailed rates of all of these processes at the same time and trying to figure out like what's the net effect. They've been doing this for about 2 years, I think, and have about a year worth of data. And so far, the general summary is that mangroves and warming seem to be increasing root growth and not so much decomposition. So we think that the net effect is going to be an increase in marsh elevation as mangroves move in and as the climate warms. Another thing is that they're putting all of these rate processes into a model called the Marsh equilibrium model. And that way they can kind of tweak things and run the model and see how long mangroves can last with different rates of sea level rise. So they can tweak the different process rates as they find out better science, or they can tweak the sea level rise projection rates and try to make predictions so that managers, throughout the reserve and throughout the world can try to figure out what to do. And so far, preliminary data, the models are estimating that mangroves can keep pace with sea level rise at a rate of about 0.7 millimeters per year. I think I might have said that wrong, if it's 7 millimeters per year. Yeah, I think it's 7 millimeters per year. And so as Mike said, we've seen long-term rates of about 2.6 millimeters per year. The last decade or so was about 5. So as of right now, we're doing okay. Today I went and I pulled a graph from that Mayport station that Mike was talking about. And these are sea level rise projections specific to that station through 2100. And the different projections go from extreme to low based on different estimates for, ice sheet melt and carbon emissions and things like that. And so if we were to stay in either the low or the intermediate low rate projections, those will both below the 7 millimeters per year will be all right. But if we end up in any of one of these high ones, then we might be facing a situation where our wetlands are collapsing. And then just to talk briefly about how we're looking at the effects of sea level rise, and Pam is going to go into much more detail about this, but I just wanted to show you some of the data that we've gotten from our surface elevation tables. And that is in this diagram represented by those little pins where it says wetland elevation change. And I wanted to show this diagram because it shows how there's a deep rod that's driven into the ground all the way to the bedrock. And that rod creates a permanent benchmark that we can measure from. And that's how we're able to measure these millimeter scale changes in the wetland surface over time. And then we survey that rod in, and it gets tied in with benchmarks on land as well as tidal data, sea level data. So here's what it kind of looks like in the field. That's Scott Eastman driving a rod into the ground, and that's one of our old biologists, Jason Lynn, measuring the pins on a set arm. And like I showed you in the beginning, we have 3 of these surface elevation tables per site, and we have 6 sites, so we have 18. So here's the data. These are data from each set, and they're laid on top of the dark blue line is the long-term sea level rise rate of 2.6 millimeters per year. And then the dashed line is the more recent 19-year water level rate of 4.66 millimeters per year. And so when you look at how the sets have been changing over time, you can see that 3 of them are gaining elevation faster than sea level is rising. A few of them are kind of right in the middle, but most of them are not gaining elevation as fast as sea level is rising. So that's kind of a big take home that causes a little bit of concern. And then I wanted to kind of set up the Sentinel site concept for you before Pam starts talking in more detail, and just to say that, the NERS system-wide monitoring program is kind of the core long-term program that all of the reserves participate in around the country. We have these standardized protocols for vegetation, water quality, weather. And the idea of a Sentinel site application module is to take those data from the system-wide monitoring program and ask a specific hypothesis-driven question. with it by adding on some other protocols, which are represented in the green circles here. And so the system-wide monitoring program wasn't ever designed to have like a specific question in mind. It's designed for researchers and managers to be able to build off of with their own questions. But a Sentinel Site application module is to take some of those data and add to it with a specific question. And so that's where the Sentinel Site application module 1 comes in, which is the first one of these modules for the nerve system, to add in looking at water levels and elevations to be able to ask a specific question, which is how does sea level rise affect our coastal wetlands? And so I think you're going to see that diagram again with Pam. And I think that's it for me. So I think we're going in terms of broad to specific, and Pam will get more specific with what we've been doing for our Sentinel site.
Absolutely. Thank you, Nikki. So we will go ahead and move on to our third presenter, Pam Markham. Make sure that you go ahead and type any questions that you've thought of for Dr. Shirley or Dr. Dix into the chat box. The chat box questions will be the first questions that we try to address when we come to the Q&A session. So be sure to get those in there, and I will go ahead and pass it on over to Pam.
All right. So can you guys hear me okay? Got a headset on, just want to make sure.
We can hear you clearly. If you're having a little bit trouble hearing her, go ahead and turn your microphone or your speakers up just a little bit.
All right, so the Sentinel Site application module, as Nikki said, we're basically within the NERS developing different tools that we can use to ask specific questions. And so our first question is really related to water levels, and that's where this module came up. So as you've seen several times now, this diagram, basically what the module presents is we measure different things in our ecosystem, but how can we connect all those things together to answer a question, which is how does changing water levels affect our marsh ecosystem or our coastal ecosystems? So to do that, we have basically 4 things that we are going to measure, and to connect those together, we use elevations. So by measuring sea level and measuring our surface elevation tables and connecting those to these what we call vertical control. So as Nikki mentioned, there's these rods set into the ground that don't move. They're stable marks. So we can actually see how does water level, which changes, and our surface elevation in our marshes, which changes naturally, how is a changing thing? Is it actually changing on a grand scale, on a small scale? Is it not really changing? So we're looking at really over time how things are changing, and the vertical control, these benchmarks that we have, are actually giving us our kind of stable mark that we can make everything relative to. So we actually held a meeting, was it 2015, I think? Caitlin, I don't remember. It was a while ago, so we held a meeting and brought people together and said, where do you think would be a great place to start applying this tool? And our overwhelming response was, let's look at Pellicer Creek. So we focused in on Pellicer Creek. It had a lot of components already existing. We have a weather station there. We have a water quality monitoring station there. And we already had some beginning data of our marsh plants and vegetation monitoring there. So we focused in on Pellicer and then took a look and said, all right, where in Pellicer do we want to focus? And this creek, if you're unfamiliar with Pellicer, actually, let me go back one. It's in the southern part of our component, and it really creates the, it actually is the county line for St. Johns County and Flagler. So the creek separates those counties if you're unfamiliar with the area. So looking at Pellicer, it's a major freshwater source to our coastal areas. So having a freshwater component was interesting because we could see, well, if sea level's rising, it might inundate into our freshwater portions of our creek. So let's actually take a look at the whole creek in its entirety and break that up and see over time what kind of changes we see throughout this creek. So we have a upper transect, which is kind of a brackish water, so not quite fresh, almost fresh. We have the middle, which is kind of a transition zone between the brackish to the more saline waters, and then our mouth transect, which is generally more saline than the other two locations. So we have this nice salinity gradient to actually look at our site and see how changing water levels can affect the whole system. So once we figured out where we're going to apply this tool, we then had to actually say what we're going to do and how we're going to apply it. So we developed an implementation plan that's a very detailed document, says exactly what we're doing and where. So that was actually a really big hurdle for us to get that finalized. It took a little over a year to write up. So that was a really big check mark for us to get that one. It's been approved. So we have started implementing the project. So to implement it, we actually have to build everything out. And so I've broken this down into the 4 different components that are required to be a Sentinel site. So we look at vegetation. We needed to install a boardwalk system, as Nikki mentioned. We don't want to interfere with the site and cause change, because then what are we measuring? The change we caused or natural change? So we actually build build a boardwalk all the way from the edge of the water up to the uplands or kind of dry ground. So those were quite a big task. Once those were installed, we then have to divide out the width of the marsh and place vegetation plots. So we have permanent locations we go back to every single time and actually take a look at the vegetation that is occurring in those plots. After that, we've got surface elevation. We've got to actually measure the elevation of the marsh. That's another one of our components. So between the SETs that we have at the mouth of the transect and actually getting elevations of our individual plots, it's going to give us a really good profile of what the surface elevation of our marshes look like. After that, we've got water level. So taking a look at how our water levels in the creek change, and there's several different kind of components to that, and I'll kind of get into that a little bit more in a minute. And then finally, that vertical control that I spoke about before, where we're actually needing to establish some permanent marks that we can get that elevations level to, so that we know that everything's connected. All those dots are connected by an elevation standard. So vegetation. We installed a lot of platforms in the marshes. It took probably just about a year, I would say, with some breaks in the middle. We don't install during the summer, not because it's hot, which I appreciate, but because it's bird nesting season, we don't want to interfere with our birds. So we've got our 3 transects installed. Our boardwalks are all there. I don't have a picture here, but as Nikki mentioned, we use these grates because it allows light down and the plants grow up, and you can actually, if you were to go out there now, you won't even see most of these anymore. The plants have grown through, and it's really fantastic. We also went through, got all of our plots established, so our vegetation portion of the build out is complete. Then we have our surface elevation. So his picture is Silas measuring the surface elevation at one of our set locations. So we do have at the mouth of Pellicer Creek, we have 3 of these installed. So those get measured twice a year. So we have that. We've also measured the elevation of the, so there's a post that sticks down in the ground. We have those elevations. We've already leveled to those, so that's fantastic. And Allie, my other biologist, and myself went out this summer and got all of the vegetation plots surveyed in. So we have elevations for all of our plots. So our elevation portion is complete at this point. All right, the water level. This is kind of our next big hurdle, so to speak, or the last big component that we're still working on. So we have installed at the end of a floating dock in the creek a platform that we can actually install a tide gauge or water level gauge. And that'll give us very highly accurate, very sensitive water level data that we can then use to extrapolate out within the creek and determine how our water levels change over time. Now, if you notice, there's a little pipe sticking off of this. This is where one of our data sondes are located. So we can actually test our water level gauge to our data sondes and be able to move that water level gauge later and use our data sonde. Once we get it kind of calibrated, we could use our data sonde as our water level gauge. And so we can actually move the other water level gauge to get more data elsewhere, which is a really great option. So we're still working on some details on figuring out the water level gauge. There's some programs within the NERS that are developing some partnerships with other agencies that do a lot of water level monitoring. So we're kind of on standby with that one. But because this gauge is actually located probably in the bottom third of the creek, and we're using an entire creek system to study, we actually have to look at how the water levels at each of our sites are different from each other. So we do have several other smaller studies that are in the works right now to actually understand how the flow within that creek works, and how if we have one site measuring water level, how that can be extrapolated out within the creek, and how we can kind of build out our water level profile of the entire creek. So a lot of work left to do on that one. That's our next big task that we're coming up on. The final component is the vertical control, so those stable marks. So before we even started anything, we were actually able to get a series of marks installed near that boat ramp where that floating dock is, and that's within Favorite Ike State Park. So that really established a solid control area for our vertical control. So we've actually been able to level out and to use some equipment to measure our elevation plots within the creek. So this vertical control network is primarily installed. However, we would also like to add a couple extra marks at our transects, because if we want to level to our plots, it's a millimeter level accuracy versus some of the equipment we use, which is centimeter level accuracy. If we want that finer detail, we'll need to do leveling. So we'll add some additional marks to allow us to have that option if we want it, or if it's feasible to do so. Obviously, we want finer level detail. So that one's still in the works, trying to get those marks installed. And then getting all of our different instruments, should put a little check mark. All our instruments at this point are leveled in. Our data sonde is leveled in, and all of those SETs are leveled in as well. So a lot of progress on that one, just kind of a final step for that to finish up on that one. So looking at kind of the whole picture, we're a little over halfway pretty much. The water level is really the last major component that we're working on, which is a very important one. They're all important aspects of the water levels. What we're really missing kind of in general for a lot of our stuff, we really need that detailed water level for our areas if we're trying to understand how that affects our ecosystems. But since we have our vegetation plots installed, we've actually gone out a couple times to take a look at them. So we initially went out October last year and then tried again earlier this year, just to kind of get an idea of what kind of vegetation we have along those different transects. And our official monitoring began in May. And then we went out and identified all the species that are located in our plots. So it's important to note these are just what's in the plots. So the plots are kind of randomly located essentially. So there are other species present that aren't even in this list. But as you can see from just our plots alone, we were identified 46 individual species. And if you kind of look at that breakdown there, you can see most of them are in that upper reach, so that brackish water. Not very many plants survive the more saline environments. So those middle and the lower are a little bit more saline than the upper, so there was fewer plant species present. The upper one, a lot of plants up there. And I have a huge debt of gratitude to a couple different volunteers that came out and helped me with those IDs, which is really great. So of these species, at all three locations, there's only 2 species that occur at all 3, and that is our black needle rush, the juncus, and the Bacopa monieri. So it's a little ground cover plant. It's actually a really pretty little plant. So only 2. There's each couple other plants that occur maybe in 2 of them and not on the other one, but yeah, just 2 out of all those 46 species that are on all 3 locations. So we'll continue our monitoring moving forward. We do this once a year in the spring. We need all those pre-low flowers to identify a lot of our species. And then in the winter, we will do some more elevation surveys and get some information just on how elevation changes seasonally as well, which is an important aspect to consider when we're looking at long-term changes. So with that, I'd just like to say thank you. I had so many volunteers and different agencies that have helped us just to get this build out portion done and get our initial monitoring done. So thank you so much to everybody that has helped out so far. And with that, I think we have a little bit of time to get to those questions. I saw the chat box kind of jumping.
Yeah, absolutely. Thank you so much, Pam. And thank you to all of our presenters, Dr. Shirley, Dr. Dix, and Pam. We really appreciate you taking some time to share with us a little bit more about our local sea level rise and what's happening in our coastal wetlands. We do have a few questions that have come in, and I do want to, before we get to those questions, we will stick on for as long as all of our presenters can, but it is after 4 o'clock. So if you did have a 4 o'clock call or meeting to get to, feel free to hop off. We are recording. However, if you'd like to have some of those burning questions answered, this is now that time. So Abby has a couple of questions from the chat box, and then we will open the floor up to anybody who did not type a question in to ask their question aloud.
All right. So Mike, we had a question come in for you. Do you have any idea why the rate of bed elevation at that 4+ millimeter per year site was so much greater than the others?
And Pam and Nikki, correct me if I'm wrong, but I think that's the site where the mangroves are recruiting to.
Yeah, the one with the blue line, we have a large jump in mangroves over the course of the study, or of the monitoring.
That was an easy one.
Awesome, thank you. I think you acknowledged the other questions that I saw in the chat box.
All right. Well, if any others come in, Abby, holler. And now if you'd like to ask one of our presenters a question, if you hover over at the bottom of your screen, there should be a participants button. If you click on that button, another window should pop up that will give you some non-verbal cues, including a raise hand function. So if you want to raise your virtual hand, or if you are on camera and want to physically raise your hand, feel free to do that, and I'll call on you, just like in school, and we can ask those questions.
So Steve, I see your question about animals in relation to sea level rise. We do not currently have any with our projects. Our stewardship section is kind of looking into some other animal monitoring within some of our freshwater marshes, which could potentially be affected by sea level rise. So that's kind of related. We don't currently have any plans for that. There are other visiting researchers that actually do look at a lot of different faunal responses to the changing habitat. So there may be other researchers that come in and actually do some of that work.
Great, thank you, Steve.
So I say, would it be useful to plant mangroves? That's kind of a hard one to answer. I know there are areas that are looking into that option. Mangroves are a very protected species, so I don't know. I'm not really the right person to answer that. I don't know if there's a Mike or Nikki, if you have a response to that.
Yeah, I did a quick answer to that one. The mangroves are going to come in naturally. And whether we plant them to try to jumpstart mangroves recruiting to the marshes, I think waiting for the results of the Wet Feet project, in South Florida where their mangroves are pretty much the basic habitat. Typically, you would go in and stabilize an area, either put in marsh grass or something, and the mangroves recruit like crazy. So I think once you get a black mangrove in the area, you're gonna start. You could probably go out there right now and see all the new little black mangroves around the larger black mangrove trees. However, you know, the concept, if say sea level rise rates were to increase quicker than we anticipate, and mangroves do turn out to be more resilient than the marshes, that could be an option, but we're not there yet.
Great, thank you, Mike. And great question, Linda. All right. Any other questions? And feel free, if you're having a difficult time finding your virtual hand, to type your question into the chat box still. All right, well, I see no physical hands or virtual hands raised, and I am not seeing any questions coming into the chat box. But we will be sending out the recording once it is processed, as well as all of our presenters' contact information. So if you do think of any questions as you're marinating on everything that you've learned today, feel free to reach out and ask any questions to our team here at the GTM Research Reserve. We'd be more than happy to answer them. When we do send out the contact information and the recording for today, we're also going to send out a survey. This is our second series of the GTM Talks webinars, and we would love to have your feedback on if you are enjoying these presentations, if there's a specific topic that you're interested in hearing about. So please give us your feedback and let us know what you think. Our next presentation, we are going to keep the presenter a secret, but our next presentation for GTM Talks will be on Monday, September 28th from 3 p.m. till 4 o'clock. And, oh, actually, I'm sorry, I jumped a whole nother week. It's going to be Monday, September 14th from 3 to 4 o'clock. And the presentation will be focused on the natural biodiversity here at the GTM Research Reserve. So keep an eye on the Friends of the GTM Reserve website, which is www.gtmnerr.org, and the registration information will be posted there. And hopefully we will not have a complete outage of Zoom that day, and we'll be able to send all of the information in a more timely manner to those of you who are waiting to be approved today. And with that, and seeing no additional questions, thank you all for joining us. Thank you, presenters, for your time and your expertise. And we will see everybody on September 14th.